Hello and welcome to the Unit 9 Section 4 video on transformations of exponentials. So in this unit we have talked a lot about exponential functions, how they look, how do you graph them, how do they behave in real-world situations, and the last thing we're going to cover here is how do we transform them. How do we take a simple exponential function b to the x and how do we transform it into any other exponential function. We did transformations in Unit 8 with quadratics, and we did them several units ago with linear functions. So a lot of this stuff is things that you already have seen. It's just in a different context with a different type of function. Okay, so the nice thing is that transformations, no matter the function type, if you're in a certain form, then it is going to be the same for every type of function. So in this case, we have the form f of x equals ab to the x minus h plus k. We've got our h and k in there, which tells us the translation of our y-intercept, 0, 1. Our a, just like before, is going to tell us our stretch or compression, and the sign in front of it is going to tell us if we're reflected or not. But there is going to be a reflection across the y-axis in this one as well, and we'll talk about that here. So one thing I'm going to suggest is that you look back at your Unit 8 notes. Go back to Section 4 of Unit 8 and compare this table to the one that you have here. Okay, compare the Unit 8 table in Section 4 to the Unit 9 table here in Section 4. And you're going to see a lot of this table is the same. The only difference is the function type and the examples that's going to go with it. All right, so a horizontal translation to the right and to the left is going to depend on what your h value is. Okay, and the h value follows the x value, which is followed by a minus. Okay, so if we're translated to the right, you're going to have something like 2 to the x minus 2. Your h value is positive, but it follows the subtraction operation. If your h value is negative, say negative 2, it follows that subtraction operation, but it's going to make it look positive. Okay, so just like in quadratics, if your h looks negative, you're going to the right. If your h looks positive, you're going to the left. A vertical translation up or down depends on your k value. Just like in quadratics, it's your value that's on the end. If k is positive, then you're moving up. So here we're translating up 4 units. If k is negative, such as here, then we're translating down 4 units in this case. A reflection across the x-axis, if you got a minus in front of everything, then you have a reflection across the x-axis. However, we also have reflection across the y-axis, which makes more of a difference here, because unlike a quadratic, an exponential function is not symmetric. So if we put a minus sign in front of the x up in the exponent, then you are going to have a reflection across the y-axis. And then vertical stretch and compression, if your a is greater than 1, you have a stretch. If it's less than 1 or greater than 0, then it is a compression. All right, so let's take a look at some examples. We're going to identify the transformations that occur from the thin exponential to the thick exponential. Our thin exponential in each of these examples is our parent function. Okay, so first thing we're going to do is we're going to look at our asymptote. And if our asymptote has moved, then we know our k value has moved. So here we were at an asymptote of y equals 0. Our horizontal asymptote has now moved to y equals negative 3. So our k value is negative 3, or meaning that we have translated down 3 units. Okay? Now, is there anything else going on with this? Well, if you look from here to the point that's above it, our y-intercept, you go up 1 unit from your asymptote. Do we still go up 1 unit from the asymptote and cross at the y-axis? We do. Okay, so there is no translation to the left or to the right. And then finally, to look for our stretch or compression, we are going to look from the asymptote to the point above it. So we go up 1 from the asymptote to the point above it, And so that means we have no stretch or compression. For B, we have no translation up or down because our asymptotes are in the same place. But if you look at the point above it, we do shift over 1, 2, 3, 4, 5 units. So we have translated to the right 5 units here. There is no stretch, there is no compression, and there's no reflection in either of these. These are both oriented in the same manner. For C, we have obviously a reflection happening, and that reflection is happening across the x-axis. The asymptotes are in the same place, so we don't shift up or down. And we go from the asymptote up 1 and hit our next point. From the asymptote, we go down 1 and we hit the next point. So here we're not stretched or compressed, we are not shifted up or down, we are not shifted left or right, but we are reflected over the x-axis. And then finally for D, our asymptotes are in the same place. And if we shift over 1 up 1, well, it looks like we are shifted left or right, but we could also be stretched. So let's see if we have a stretch here. So from here, from the asymptote, we go up 1. From the asymptote, we go up 1, 2, 3. So we do have a stretch of 3 here. Instead of it being shifted left or right, this happens to be a stretch. In equations, it's considerably easier to determine what the transformations are, okay? So all we have to do is look at the pieces of our equation. So in A, there's no negative out in front, so we're not reflected across the x. We do have a number greater than 1, so we do have a vertical stretch of 4. And then we have 3 to the x. There's no minus in front of the x. There's no number following the x, but we do have a number on the end, -5. That means that we have translated down 5 units. For B, no minus out in front, but we do have a number. The 3 tells us that we are stretched by 3. And the +1 following the x tells us that we have shifted to the left 1. For C, we have a negative out in front, so we're reflected across the x-axis. 8 is greater than 1, so we are stretched by a factor of 8. And there's nothing else happening. We have 3 to the x, which is our exponential parent function, and nothing else is happening. In D, the 2 out in front tells us that we are stretched by 2. And then we have a -3 following the x, so that we are going to the right 3 units. And then a +4 on the end of everything tells us we're translated up 4 units. In E, we have a minus out in front, so we are reflected across the x-axis. The 1/2 tells us, or at least the 1/2 out in front, just following the minus, tells us we are compressed by a factor of 1/2. The 0.5 to the x is just our parent function in this case, okay? It doesn't matter what your base is. That is not going to be part of the transformation because you're going to have a different parent function. You have different parent functions for 2 to the x, 3 to the x, 4 to the x, 1/2 to the x, and so on. And then for F, 6 out in front tells us we're stretched by 6, and that is the only transformation happening in this equation. All right, now that we're able to determine some of the transformations that occur, we're going to use those transformations to be able to write the function or the equation of the function when we're given a graph, okay? And in each of these cases, you're going to be told what the parent function is, okay? So the first thing you're going to do is identify the horizontal asymptote. This is your k. Find the point nearest to the horizontal asymptote. The x value is h. Then we're going to determine how many units the point is away from the horizontal asymptote. This is your a. Using the given parent function, we will plug a h and k back in without the values plugged in for x and y. Okay, so for a, first we're going to find our asymptote. Our asymptote is at y equals 5, so our k is 5. Then we're going to find our point that is above the asymptote, which is, in this case, 6. So this is y equals 6. We want the x value off of it. So our h value is 0. And then how many units the point is away from the asymptote is 1. So our a is 1. So we have y equals, a is 1. We don't have to write the 1. 2 to the x. Our h is 0, so nothing to follow the x, and we just put a plus 5 on the end of it. In b, while we do have a asymptote at 0, our point is going to be at 0 because our next unit up, our x value is still at 0. We are reflected, however, reflected across the x-axis. So our a is going to be negative, and since we're not stretched or compressed, it'll be negative 1. So in our equation, we're going to lead with a negative. Our k and our h are 0, so all that's left to write is 2 to the x. For c, we have x equals, or y equals 0 is our asymptote, so our k is 0. Then we're going to find the point above our asymptote, which is out here at x equals 5. And then we are 1 unit above our asymptote, so we have a of 1. So y equals 2 to the x, and our h is 5, so minus 5. For d, now our asymptote has moved. We have moved up 4 units, so k is 4. Our h is still going to be 0 because we're 1 unit down. X equals 0 at that point. And then our a, well, we are reflected across the x-axis again, so negative 1. No stretch or compression here. And so y equals negative from our a, 2 to the x, nothing follows the x because h is 0, and then plus 4 on the end for our k. And then finally, we're going to look at e here. Our asymptote has moved up 2 units, so k is 2. And then if we go up 1, we're no longer at x equals 0. Now we're at x equals negative 4, so our h is negative 4. And then we are not stretched or compressed, and we are also not reflected, so a is 1. So we lead with the 1, which we don't have to write. 2 to the x, h is negative 4, so it's going to be plus 4. And then k gives us the plus 2 on the end. All right, that finishes off Unit 9 on exponential functions.